Hello, this is our final project for CPE 185. The name of the project is Climate Control Device. It is completed by Mykola Golubятnikov and Natalia Golubятnikova. Team members' responsibilities were shared in the following way. For Mykola, it was to build a breadboard, write a code, video editing, and preparing a lab report. For me, it was to draw block diagram, FSM diagram, participate in writing a code, video editing, and writing a lab report. For the final project, we want to build a climate control device for home use. This is going to be a device that with help of temperature sensor or thermistor, detect an external temperature, and when the measured temperature corresponds to one of the states, then the appropriate lights turn on and IC or heater turns on accordingly. If the temperature is a room temperature, the idle LED turns on. As a temperature sensor, a thermistor was used. Thermistor is a resistance thermometer or a resistor whose resistance is dependent on temperature. The term is combination of thermal and resistor. It is made of metallic oxide pressed into a bed disc or cylindrical shape and then encapsulated with impermeable materials such as epoxy or glass. For the block diagram, we have the temperature sensor as an input to STM32 breadboard, development board, and for outputs as an air condition, idle, and heater. For the FSM diagram, the first state is temperature determination state, and after temperature reading, if the temperature is room, then the corresponding LED turns on, and passing another measurement, the idle LED turns on. Once task is complete, it would return back to the temperature determination state. If it determines the temperature is cold, then cold LED turns on and passing another reading, the heater LED turns on. And after that, if it turns back to the temperature determination state. If it determines the temperature is hot, then hot LED turns on, and after reading again, the AC LED turns on, and from there it would cycle back to the temperature determination state. For our project, we have thermistor as a temperature sensor, 6 LEDs, 6 330 ohms resistors. For hardware platform, it was STM32 Nuclear F303K8, and we use software STM32 Cube IDE and MobaMax Xterm.
So for the test case 1, we set the temperature from 76 to 77 degrees, which is our current room temperature. On the left picture, the terminal shows us raw value, voltage, states, which is room, and idle LED. Idle LED on, and the temperature in Fahrenheit as well, we can see on the left picture. So on the right picture, we can see our LEDs turn on, which represent room state and idle state condition. For the case 2, we set the temperature less than 76 degrees. As we can see, the terminal shows state cold, so heater LED on. For this test, we used iSpec applied to the thermistor, so the temperature went down, and green LED, which is cold state, turn on, and red LED heater on. For the last test case, the thermistor was warmed up with a hand. We set the temperature above 77 degrees. We can see the terminal shows hot state, so AC must be on. We set green LED for AC on and red LED for hot state. So for the quick demo, we can see the idle state. Right now, it's a room temperature, 76, more than 76. It's between 76 and 77. And now I'm going to warm up with my hand, we can see the hot and AC on state. The temperature increased, and now we're going back to the room, and then we try ice pack for the cold condition. We can see now the green LED, which is cold state, heater on, red light turn on, temperature below the 76 degrees, and then our system works perfect. We're happy to do this project, and then as we can see now, our system is going to turn back to the idle state, which is room condition. So in order to help, just it's back. We can see 76, between 76 and 77.
For our final project, we were able to design climate control device for home use. Our project includes block diagram, finite state machine diagram, wiring, coding, and testing. We went through 3 test cases and we wrote the code with temperature ranges below 76 Fahrenheit, 76 to 77 degrees on Fahrenheit, and above 77 degrees. In practical use, the temperature preferences could be adjusted in any way. With temperature condition changes, our device responded by transferring from one state to another and providing LED lights on off.